Today we're going to start section 6.5, and basically the lesson will use properties of logarithms, and they're very similar to properties of exponents. And the reason why we're doing this is we're going to be simplifying computations by using these properties. Now, first thing you want to do is turn to your journal, page 328, and look at the vocab words for base. Remember, base would be the number that has the exponent. So here the base would be b. Or if we have 3 to the x, the base would be 3. Okay, so these two are the bases. For properties of exponents, you know one property. If I were to multiply b to the m times b to the n, what do you do with the exponents? You're going to add them. Another property, if I have b to the m divided by b to the n, when we divide, we're going to subtract exponents. Or if I have b to the m raised to a power of n, you're then going to multiply the exponents. So using those same properties, we're now going to do properties of logs. Remember, logs are like exponents, so we have product property. If I have two numbers, m and n, multiplied, I can expand it into two logs being added together. If I have division, m divided by n, I can expand it into a subtraction problem. If I have power to a power, I could bring the power of n to the front and make it a multiplication problem. So again, product changed to a sum, quotient changed to a subtraction, and power changed to a multiplication. Now let's look at the examples in our notes. In example 1, we're working with just numbers, and hopefully you can see that before we go to the variables. So in A, we have a division problem. So what we can do is break up in a division into a subtraction. Log base 2 of 3 minus log base 2 of 7. And then we know this number because it's given to us above. And we know log 2 of 7 is given to us. So then we can subtract the 2 and get a final answer of negative 1.222. 21 is basically 3 times 7. So think of 21 as 3 times 7, and then you can expand the multiplication problem into an addition problem. So we can add 1.585 plus the 2.807 and go to a total of 4.392. 49 you can think of as 7 squared. So we have a power to a power. You can expand it into a multiplication problem by moving the power to the front and doing 2 times log base 2 of 7, or 2 times 2.807 and get 5.614. We'll save the monitoring progress for class. Let's move to example 2. For example 2, we're now dealing with variables also. I see 5 is being multiplied to x, and x has a power of 7, and we have division of y. So we have all three of these things happening. So let's start off by the division of y. Dividing by y, we're going to convert into a subtraction. So I have ln of 5x to the 7 minus ln of y. So the division turned into subtraction. Now the ln of 5x to the 7th, we can expand, and multiplication will turn into addition. And then we still have an exponent, and we're allowed to change exponents into multiplication. So you're going to move your exponent right to the front. So our final answer for expanding this logarithm is ln of 5 plus 7 ln of x minus ln of y. Example 3 was cut off, so if you could please copy down the problem. We're going to be doing the opposite of example 2. Instead of expanding, we're going to be condensing. First thing you want to look for is any exponents we can move. Notice this 3 here being multiplied to the log means we can turn it into an exponent. So I'm going to convert the problem to log 9 plus log 2 cubed minus log 3. Then I have 2 logs being added together. Addition means they were originally being multiplied. And then I have subtraction. And subtraction means they were originally being divided. So I have 9 times 2 cubed all over 3. And then we can actually calculate this. Since 2 cubed is 8, 8 times 9 is 72, and 72 divided by 3 is 24. So my final answer will be log of 24. I apologize for the squished writing. We'll try the monitoring progress in class. Please let me know if you have any questions.